Next, we are going to discuss a graphical question. A ball is dropped vertically from height d above the ground. If it hits the ground and bounces up vertically to a height d by 2 or a h by 2, then which of the following graph represent correct graph for its velocity versus height? Okay, this is a simple question. So whenever the ball is dropped from height h, then what happens? Its velocity is increasing gradually when it approaches the ground. That means its velocity is gradually increases in negative direction. We take a upward direction as positive and downward direction taken as a negative. Right, this is dropped body. We know that v square is equal to formula u square plus 2as. V square is equal to u0, that is equal to 2gh. This is a parabola equation. So the nature of the graph is a parabola. Okay. Now, when the ball reaches the ground and rebound to a height h by 2, its velocity again becomes positive. Its velocity again positive. Okay. That means it reaches to the height, how much height? It reaches to the height h by 2. It reaches to the height h by 2. Its velocity is gradually decreases. Gradually decreases in positive direction. Okay. So from this information, we conclude that the correct graph is this. This graph is correct graph. Okay. Here, the body, whenever the body falls from height h, then what happens? Height decreases. Height decreases, velocity increases in this direction, negative direction. When the ball is strikes the ground and rebounds to a height h by 2, then what happens? It has some magnitude of velocity, but that is less than previous case, and the velocity is gradually decreases, and becomes 0 at a height h by 2. So among the following graphs, the correct graph is the first one graph. Here see third one, there is no linear relationship between velocity and height, but that is not correct. See the second one, here velocity has a positive direction, but that is not correct. In both cases, velocity has a positive direction. See that fourth option, velocity has a negative direction in both cases. No, fourth option is not correct. So among four options, the correct one is option 1. Option 1. Okay, now we are going to discuss another question. Two charged thin infinite plane sheets of uniform charge density sigma plus sigma minus, where sigma plus is greater than sigma minus, are placed along xy plane and yz plane respectively. Xy plane and yz plane respectively. Then the nature of the electric lines of forces. Then the nature of the electric lines of forces. Which of the following is correct? Which of the following is correct? Right. Here, infinite plane sheets of uniform surface charge density. So they are placed along xy plane and yz plane. Okay. yz prime. This is sigma plus positive charge density plate. This is negative charge density plate. Negative charge density plate. Now they gave 4 options. Now we want to find out which option is correct. Okay. Right. Let us take one point in this coordinate. Due to positively charged density, the electric field is away from the plate. Due to the negative charged plate, the electric field intensity is towards the plate. Okay, towards this side. So, as a result here, the resultant electric field intensity is exactly not 45. This is very close to the electric field intensity due to the positive charged plate. Okay, we know that here E plus is equal to sigma plus by epsilon naught, E minus is equal to sigma minus by epsilon naught. Okay, here E plus is greater than E minus. E plus is greater than E minus according to given problem. So that the resultant electric field intensity is not exactly 45 degrees. It is very close to the E plus. It is very close to the E plus. Okay. Right. Now we take one more point here in this coordinate. Okay, due to this positively charged sheet, the electric field intensity is along this direction. Due to this plate, the electric field intensity is along this direction. So since sigma plus is greater than sigma minus, this is electric field intensity due to the positive charged plate. This is electric field intensity due to the negative charged plate. Due to E plus is greater than E minus, the resultant electric field intensity is not exactly 45. Okay, it is very close to the E plus along this direction. Similarly, we consider here one point. Due to the positive charged plate, the electric field intensity is along this direction, E plus. Due to the negative charged plate, the electric field intensity is along this direction. This is E minus. As a result, electric field intensity is not exactly 45. It is towards E plus. Towards the E plus. Okay. Along this direction. So similarly, if we consider a point in the fourth coordinate, the electric field intensity due to the positive charged plate is E plus along this direction. The electric field intensity due to the negative charged plate along this direction. This is E minus. As a result, what happens? E plus is greater than E minus. This is resultant electric field intensity direction. This is it is not this direction is not exactly 45 degrees. Okay. So among the following, so option 2 is correct. Option 2 is correct option. The electric field lines are looks like this direction. Looks like this. Okay. So this is the correct option. The resultant electric field intensity is not exactly at 45 degrees. This is the twist in question. Okay. Right. Okay. Now let us discuss another question. Gravitational field intensity is given by E is equal to A into x by a square plus x square whole to the power of 3 by 2. Find out potential at x. Find out potential at x. So here this is x is equal to 0. This is x is equal to x. This is x is equal to infinity. We know that here at infinite distance the potential is 0. This 0 potential point we taken as reference point. Reference point. At x is equal to x, Ex is equal to here a into x by a square plus x square whole power 3 by 2. Now we want to find out what the potential at x. They given at x is equal to at Ex is equal to ax by a square plus x square whole power 3 by 2. They given. Now we want to find out what the potential at x is equal to x. We know that there is a relationship E is equal to minus dv by dx. Okay, minus dv by dx. So here minus dv is equal to what we write here, E into dx. E into dx. Now we integrate above equation. Integration of dv is equal to integration of E into dx. So v is equal to minus integration of E into dx. We take limits. Here we take limits from infinity to x. From infinity to x. Right. Now v is equal to here we take minus integration of, what is the value of E here, ax by a square, a into x by a square plus x square whole power 3 by 2 into dx. Now we are going to integrate this equation. So let a square plus x square is equal to t. Now differentiate this equation. 2x dx is equal to 2x dx is equal to, here we write dt. X into dx is equal to what we write here, dt by 2. dt by 2. Substitute. This is equation 1 and this is equation 2. Substitute 2 in 1. So v is equal to minus integration of infinity to x a, okay, x into dx is equal to, how we write, dt by 2 a square plus x square is equal to t power 3 by 2. T power 3 by 2. Now v is equal to minus a by 2 integration of 1 by t power 3 by 2 into dt. 1 by t power 3 by 2 into dt. b is equal to minus a by 2 integration of 1 by t power 3 by 2. What we write here, t to the power of minus 3 by 2 plus 1 by minus 3 by 2 plus 1. Okay, infinity to x. Infinity to x. So, right. Here v is equal to minus a by 2 a by 2 to the power of minus 3 by 2 plus 1 minus 3 by 2 plus 1, here minus 1 by 2 minus 2 2 to the power of minus half, 2 to the power of minus half. Okay, so V is equal to, here minus 2 cancel, minus cancel, minus into minus plus 1 by root t, 1 by root t, that is equal to here a by root t. A by root t means what? Root of a square plus x square. So what is the potential here? V is equal to a by root t, that is equal to a by square root of a square plus x square. So this is the answer. Here let us see another question. Here there is a given in figure shows that few data points in photoelectric effect. Okay, for certain metal, the minimum energy for ejection of electrons from its surface is. Okay, this is a graph. Here few data points are given in photoelectric experiment. Here this is 5.5 comma 0, this is 6 comma V. We take stopping potential on y-axis and frequency on x-axis. Now we want to find out what the minimum energy for ejection of electrons is. So the minimum energy for ejection of electrons, what we call work function. That is a work function. We know that Einstein equation h nu is equal to half mv square plus w, half mv square plus w. H nu is equal to E into V naught plus w, E into V naught plus w. Here the stopping potential is 0. Here 5.5 comma 0. Stopping potential is 0. So substitute that value in this equation. H nu is equal to W. H nu is equal to what we get here? W. So here H value is, now W is equal to H nu. H is equal to 6.62 into 10 to the power of minus 34 into mu frequency, 5.5 into 10 to the power of 14. The answer is given in electron volts, so that we must divide this equation with 1.6 into 10 to the power of minus 19. Okay, now 6.62 into 5.5, we get here 36.41 into 10 to the power of minus 1. Here 10 to the power of minus 19, bring this to the numerator, 10 to the power of minus 1 divided by 1.6. So W is equal here 22.75 into 10 to the power of minus 1. So W is equal to, we get here 2.27 electron volt. This is the correct answer according to given data. So now let us discuss another question. Two concentric circular current carrying arcs of radius R1 is equal to 3 centimeters and R2 is equal to 2 centimeters, and the direction of current in both are as shown figure. Find the ratio of magnetic fields B1 by B2. That means bigger arc to the smaller arc at the center produced by both arcs. This is the direct formula based question. The magnetic field at the center, produced by a arc B is equal to mu naught I by 4 pi r into theta. Mu naught I by 4 pi r into theta. Okay. Now, the magnetic field produced by bigger arc at the center BA is equal to mu naught I by 4 pi r into theta. The angle subtended by the bigger arc at the center is, here they given here bigger arc is 90 degrees. This remaining angle 2 pi minus pi by 2, equation 1. 2 pi minus pi by 2. And the magnetic field produced by a smaller arc at the center BB is equal to mu naught I by 4 pi r into 2 pi minus, so smaller arc. Okay, smaller arc angle is equal to how much here? 60 degrees. That means 2 pi minus pi by 3. 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 This is equation 2. Okay. Now, ratio of magnetic fields to the bigger arc to the smaller arc. Mu naught I. I means how much current is passing. Current is same. Current is same in both arcs. Okay. 2 by 4 pi into bigger arc radius 3 into 3 pi by 2. This is equation 3. Okay. Divided by mu naught into 2 divided by 4 pi into, what is the radius of the small arc? 2 into 2 pi minus pi by 3. 2 pi minus pi by 3 means how much? 5 pi by 3. 5 pi by 3. Okay. Now, the ratio of magnetic fields due to the bigger arc to the small arc is equal to, here, mu naught into 2 into 4 pi into 3 into 3 pi by 2, 4 pi into 2 into 3 divided by mu naught into 2 into 5 pi. Okay. So here what terms are cancelled? Let us check. 4 pi cancel. Okay. This is 3, this 3 cancel. This 2, this 2 cancel. And here remaining all cancel. BA by BB is equal to this 3 cancel. Okay. This pi cancel. Mu naught cancel. That is 6 by 5. So answer is 6 is to 5.